Okay, so this is a question about magic squares. So let's start by talking about what a magic square is. So I've drawn a magic square of order n equals 3. So this is an n equals 3 magic square. And you can see that what this involves is taking the numbers from 1 to n squared, so 9 in this case, and arranging them in a square so that the sum of every row, every column, and the diagonals is 15. So you can see that if I sum up these numbers, it equals 15. Same for all the rows, same for the diagonals, and same for the columns. So they all sum up to 15. Okay, so that's a magic square. Now the first part of the question is really just a mathematical question. So it's asking you that if a magic square of order n exists, what must that sum actually be? Okay, so we can work this out in a fairly straightforward way. So what we're trying to work out is the sum of one row. Let's call this S. And we know that in our magic square we've got n rows, and each of them must be adding up to this number S. So in total the sum must be n times S. But we also know that this sum is, this magic square contains the numbers 1 to n squared, so that must mean that we have n times S equals the sum from 1 to n squared. And if we just use the rule for computing a sum, we get that it must be n squared times n squared plus 1 over 2. And if we rearrange, we end up with the rule that the sum of each row must be n times n squared plus 1 over 2. Okay, so now if I say, right, I want a magic square of order n, I can compute S, and then I know what sum each row, column, and diagonal should be. Okay, so that's the first part of the question. The second part says, design an exhaustive search algorithm for generating all magic squares of order n. So remember, exhaustive search means that you generate all possible combinations and test them. Okay, so in this case, what we're talking about is all possible permutations of the numbers 1 to n squared. So let's take a simple example. Let's take n equals 2. So we're thinking about a magic square that looks like this. So we can start by enumerating all possible permutations of the numbers from 1 to n squared. So this would look like 1, 2, 3, 4, maybe 1, 2, 4, 3, 1, 4, 2, 3, and so on. And all we need to do is decide on some rule for how we're going to position them. So maybe we put the first number in the top left square, second number in the top right square. So we're basically just doing this in raster scan order. Okay, so we've tried our first permutation, we've arranged them in a magic square, and now we just test if this meets the criteria that we've just decided a magic square must meet. So we said that the sum must be n times n squared plus 1 over 2. So this time we've got n equals 2. So we've got 2 times 4 plus 1 over 2. So we know that the sum must be 5. Okay, so now we've got this, we've generated this possible magic square, but we can see that the sum here is 3. So this one is not valid, so we can discard this one. And the algorithm is now just going to work through all permutations, testing every row, every column, and every diagonal. As soon as one of them doesn't sum to S, we discard it. If we find one that does, then we label it as one of the possible magic squares. So that's it.